Hey everybody, welcome back to another Azure FunBytes. My name is Jay Gordon. Hope you're all doing really super cool today. I am really happy to be part of another great stream. Give me 1 second. I think I'm a little choppy at the moment. Sometimes when you do it and you do it live, weird things happen. So let's give me 1 second to figure out my camera thing. But anyhow, before we kind of get started with the show, I actually want to just give you all a brief intro of who we're going to have on today. Zach zdeptawa is a really great coworker of mine. We get to do a lot of interesting things around Azure, and today we're going to give that a shot. So before we get started, I'm going to go ahead and show you this video, okay?
So should you use Azure Resource Manager templates or something like Terraform for your environment? And this is a very environment-specific question, and it's going to depend on what you're currently using. If you're already using ARM templates or Azure Resource Manager templates, then you can go ahead and continue using them. But the big difference is ARM templates are built for Azure. They deploy resources inside of Azure. Terraform uses the HashiCorp configuration language, and it can deploy across multiple clouds. It's kind of cloud agnostic. It uses a provider and resource model, whereas ARM templates only deploy Azure resources. So if you're trying to deploy across a portfolio of clouds or a portfolio of environments, even on-prem environments, Terraform would be a really good choice. Now, if you're already using ARM templates and you want to look at something like Terraform, that's totally cool and that's great. You can actually deploy ARM templates using Terraform. Terraform has a resource to deploy an ARM template. So say you've already got one and you're using it now, you can still use it and you can start transitioning into Terraform if need be.
Well, that being said, we've got Zach zdeptawa. Sorry, I have mumble mouth.
That's okay.
Thank you for joining me here on Azure FunBytes, where I think we're going to have a really cool kind of show. We're going to do some interesting stuff, and it's going to be something that I think kind of keys into a big part of what we're going to be thinking about when we want to start working with the cloud, and that's ways to build in the cloud that make sense, that are repeatable, and don't always have to be for our specific cloud provider. So I think that we're going to solve a couple problems today, and Zach, I'm really glad you're going to help me with this. So thanks a lot for coming.
Yeah, no, I'm super excited to be here. As Jay mentioned, I work with Jay at Microsoft, and I focus a lot on DevOps and infrastructure as code. So I'm stoked to be here to talk about it.
Very cool. Well, it's always great to have another member of the team part of this because, you end up being really lucky. And I say this every time I do one of these shows. You end up being really lucky that you meet some really awesome people that you get to work with. But when we get to actually do work together, I think it's even more special. So thanks a lot. And before we kind of talk about what we're going to do today, I want to learn a little bit about you, if that's okay.
Yeah, no, that's totally cool, man. What would you like? Just some background or what's anything specific?
Sure. So I know you're a cloud advocate and you've got a lot of focus on infrastructure as code and a lot around Terraform, but I'd love to hear where you got started in technology and how it really started being a huge part of your career.
Yeah, no, that's awesome. I actually have kind of a weird background in technology, but I started messing with computers when I was probably 8 or so years old. We were lucky enough from my dad to buy us a family computer. And I remember when we had to like park the hard drive and all that, we were freaking out. Like, can we turn this thing off or is it going to explode? You know, what's going on? But when I turned 18, I got a job, luckily, at a small computer company in San Antonio, Texas, doing computer repair, building new computers, and they really taught me everything. I got a lot of on-the-job experience, and from there, I went to a hosting company, and started as a monitoring tech and just started listening to, I would write these alerts, like, here's this alert, this thing is broken, and I'd send it to a tech. And then I would go sit with the tech if I had time and say, how are you fixing this? Like, what's the problem? And it kind of all spiraled from there. I started taking on different roles, it went from a support specialist to an administrator to an engineer to a solutions architect. And I've just kind of bounced all around pretty much everything but pure sales. I've done in the hosting arena. And that's sort of what's led me here. I've done talks before to C-level. Working as a cloud advocate at Microsoft is the first time doing one-to-many talks where I'm not talking to a specific company, if that makes sense.
Sure. Yeah. And I get that. I used to work for MongoDB, and I was a vendor, and I spent a lot of my time as a DevRel or advocate person getting people to understand why they should use that. Now I feel like I'm a little bit more generalized because, sure, I'm talking about Azure, but I'm not just focused on one particular technology, and I get a lot of enjoyment out of that. So, speaking of, we're going to work through some problems today, and I always like to have fun on the show and kind of work through some problems when you're doing these things around Azure. So let me skip my backup because it's slowing down my computer. I finally figured out why everything's working a little slow. Next time I gotta remember to unplug my backup drive while I'm running. So if you give me all a second, you'll see me, I think, start to kind of have less problems. Got to remind myself in the future not to unplug before I go to start the show.
Oh, it's totally a learning process, and like, we're doing this completely live, so not a problem at all.
Cool. So I'm just going to stop my camera and fix it. But what I would love if you could give us a shot, Zach, is give us a quick explanation on what do you think are the big ideas around infrastructure as code.
So this kind of goes back to, I guess I could even talk through kind of my career. So I at the first hosting provider I worked at, we were doing purely dedicated hosting. This is probably going to age me a little bit, but we were doing, rack and stack kind of deployments. It took weeks to build stuff. If we wanted, like, say, Christmas is coming or something like that, we would have customers that would put in requests months ahead of time to get servers racked, configured, and ready for that holiday kind of explosion. And then from there, we had the VMs virtualization that popped up, and that's when I started dabbling with DevOps, infrastructure as code. Like, okay, we have these cool things that we can deploy quickly, but like, I don't want to do this all the time. Like, I don't want to stand them up and tear them down. I don't want to manage it. If I do stand it up and tear it down, I want to be able to do that easily again later. So the whole idea of, as a Linux engineer, which is kind of my background, the idea of scripting out as much of my work as possible is kind of what led me to this. And so the idea for infrastructure as code is to be able to do things in a consistent, repeatable manner, in a reliable manner as well.
Sure. So one of the big things, and I'm going to bring up my screen now if you give me a second, that one of the big things that's part of Azure Fundamentals, and you can check a look if you're in the chat. I'm going to throw some of these links here, and I think that they're really useful so you can have them for the entire show. They're all here in the chat. Hopefully you find them interesting and useful. If you don't, if I know it's a little bit of a mess, I'll have them all in the show notes. You'll be able to see it. So what I think is great here is you get an idea of all the cloud concepts and everything, but it gets to a point where you got to move beyond concepts, and you actually have to start working and building and creating with these things. And so there's a lot of different products out there that can help you start that process. And one of the things that's really interesting about Azure is there's kind of an infrastructure as code that built into it. And so while I'm going ahead and building a VM, would you give everybody just a quick idea of like what's going on when I'm doing this and creating in the front when I get to the template? So can you give us a brief intro on ARM templates? Just 30 seconds. What would you say an ARM template is?
So ARM template is effectively, it's code that defines your environment, that deploys things inside of Azure. ARM stands for the Azure Resource Manager, and so an ARM template you can basically deploy and manage your environment inside of Azure. The thing with ARM is it's Azure specific. It's not cloud agnostic. It's only going to work in Azure, and so that's where you get into things like Terraform or other kinds of configuration infrastructure as code tools like that. Yeah.
So when you build something on top of Azure and you're creating a new VM or something, you're always interacting with the Azure Resource Manager, and that's essentially what ARM templates are for, to build something for Azure Resource Manager. So I'm just going to show you. I'm just going to use a bunch of defaults. I'm not going to really do anything interesting. I just want to show you. You'll get through this whole process, and eventually you get to advanced, tags, review, and create. So while you can build all these things in the portal, what I think is really interesting is that there's actually an ability to use all the stuff that we've created here in a template. So what we can do is download a template, which is essentially all the instructions that we want when it comes to creating a new virtual machine. And if you can see here, we've got variables that set different eventual parameters that we want. And so right here, Zach, let's talk a bit about how this kind of looks. So location string, that string is being filled in the actual template by the resources that we want to create. So when we say what location, eventually within the variables we provide, we say we want to be in East US or whatever particular region.
Yeah. So the parameters that you show there at the top, what it's actually doing in that template is initializing them, and that's why it shows like location and the type is string. So you're exactly right. You're initializing all of those variables, and you can use them later inside the template. The cool thing is, like you said, the portal built that for you. So like out of all the things you were doing, here's the template that you can use to do it later as well.
So let's get on to our next one. So I want to make sure everybody sees there's a few pieces of documentation that'll help you get started. But when you want to think about it in general, infrastructure as code is just one of the big bases of working with Azure. So we've got a question from Root. And Root wants to know infrastructure as code for stateful versus stateless using Terraform ARM templates. How do we achieve this for both of them?
So, and Root, correct me if I'm wrong here. You're talking about tracking state for your infrastructure versus just firing and forgetting the infrastructure. So something like Terraform and ARM, they're going to track the state of your infrastructure. So if you stand up something using Terraform or ARM, you can track the state of what changes if you're going to make any changes to it. The way Terraform achieves that is it uses a TF state file that's local, but you can also have that set up to something external like Azure Storage. So you have a centralized state location where it can track that state as well. I hope that answers the question.
Yep. Thanks, Root. And if anybody else has questions or comments or they want to take part, remember, you're a part of this all as well, and we really, really appreciate that. So obviously, we talked a little about ARM templates, and templates, like I said, are files. The files are made up by parameters, variables, user-defined functions, resources, and outputs of what happened. So a portion will look like this, and then the output would kind of go like this. There's a 3-tier template that, say, has all the different tiers that you want to be produced when you create, say, a full application deployment. We can set in our template, we want to build a virtual machine, we want an app service for that, and we want that app service to connect to an SQL DB. And then the thing we also make sure is that we all want that to happen in a resource group, because resource groups are kind of like, here's the way I like to put it, Zach. I like to look at resource groups like empty cartons of eggs. Because the thing that's great about an empty carton of eggs is no matter what is inside of it, all these resources, if one of them goes bad, we could pull it out and we could put another resource in. Or if we think this egg belongs in another carton, we can move it over. And if all the eggs inside of our carton go bad, we don't have to take them all, each one. We could just throw the carton away. And so that's kind of the way I like to look at the resource group. And so all these eggs are being placed into a carton from a simple template. This template is telling it, do this, do this, do this. So what you can do, and I'm going to share this document, is you can create and deploy your first ARM template. And one of the things, Zach, I don't know, have you played around with the extension here?
I actually haven't. No, so yeah, inside of VS Code. I'm sorry, I couldn't tell if that was on your browser or not. Yeah, I have a little bit, but not too much.
Sure. So that's the great thing is if you're building ARM templates and you need to customize it, you want auto completion, snippets, things like that. It's even built into VS Code. I think that makes it a really powerful tool because you can get the right kind of linting for what you need while you're building it, and auto completion of certain variables that are important when you're building with ARM. So let's just kind of show you. You can create your first template pretty easily by just copying some JSON, and that's what these templates are. It's just JSON. So there is a lot of requirements to make sure that you have a schema, that it knows exactly what it's going to be using, and then you actually need to add resources. And so once you add resources, you're able to start identifying the different things, where you want them to be. And this is all really important. So I'm going to kind of shorten this and share it for everybody. There you go. And so you can also go to template references and use that to determine what exactly you want. So that's another great doc, but I think the one that I really think is useful for everyone here if they want to get started using templates is these are templates for quick starts. So I'm going to just share that in the chat with everybody. Anybody in the chat ever use one of these quick starts? Please let me know. I'd be curious which one you've used. I'm going to go ahead and just pop over. If you want to, this is a short link to go check out the previous doc. And then here is a link to the quick starts. And so these quick starts, Zach, you want to just give us a quick rundown?
Yeah, I mean, just like you said, these are quick starts that are going to help you get started as quickly as possible and as easily as possible. There's a ton of great documentation around exactly what you're doing as well. So it's not just the code, copy, paste, and do it. It's literally all of the code and a ton of information around it.
Yep, and if we actually go to one of these quick starts, what we can see is that it is like most things that we're going to be working with. It's open source. And so what we can do is take a look at it. We've got just some bits of JSON, and it's an Azure Deploy stating the information that you want to use, the password, the secure string for your SSH for this Linux server. And along the way, we have some parameters. So a username, a password that we can go ahead and set. And if we actually have this all in secrets, we can have this passed over an encrypted way. So we don't have to pass it in plain text. And then we actually also have our metadata on what is going to be created, and that's obviously useful for tagging long term. So this is kind of just an idea of how it works, and you don't really need to do anything crazy to deploy one of these. There's always, in a lot of these quick starts, a deploy to Azure button. And so if you click deploy to Azure, and so this is just getting started with using infrastructure as code right out of GitHub, right into the portal. So as you say, if you're already authenticated in Azure and you go ahead and you click one of these deploy to Azure buttons, what you're going to do is get a portal-based way of using a template. And so that template can be as easy as just going ahead, selecting the resource group where everything's going to be, filling in the username, password, setting it some of the other parameters that aren't already set by that template. We've got some stuff we already predetermined we want. We just had to add the extras, like our username and password. We click review and create. It does a validation. I didn't fill it all the way out, so it's going to fail. And then eventually, it'll pass it on to Azure Resource Manager and go. And of course, there's CLI methods of doing it. You can use your favorite API if you write in a specific language. or I should say, use your favorite language to use an API or something like that. And so the next part of this is we've took a big look at native Azure stuff. And I think that gives us a second to kind of talk about when you want to get non-native and why you would want to move to a non-native method of infrastructure as code. So you want to give me a quick breakdown?
Yeah, sure. So just out of my own experience, we have a lot of customers that are sometimes new to Azure. Sometimes they have resources that span other cloud providers. Sometimes they have resources that are actually internal and proprietary on their on-prem. And something that is not proprietary or something that is not only built for Azure will allow you to span multiple clouds, multiple locations. And really what something like Terraform does is it's actually obfuscating the API calls. So anything that has an API, you can interact with it. If you have your own proprietary system, you can actually write your own provider for it. So not only could you use major cloud providers and things like Kubernetes providers, for example, you could write your own provider for your own internal proprietary infrastructure as well. So it really is more about having your whole portfolio, be it wherever it is, managed under the same place for infrastructure.
Cool. And so that gets me to what we're going to kind of chat about first. And so I'm going to take the super noob approach. Okay. And so the super noob approach that I'm going to do is I'm going to show everybody how to install it.
Yes.
Because that's really the one cool thing that I think that we can talk about is that it's extremely intuitive to get started with the installation process. Now there's going to be one of two ways we can do this, and I'm going to show you one, then I'll show you the other, and then once we get past this, I think what Zach, I'd love you to show me how to like kind of start working with this once you've got it installed. So as you can see, if you go right here, it says download CLI, and the Terraform CLI is available for pretty much every operating system. You name it, it's there. But one of the things I really love, because I'm a Mac nerd, I don't want to download binaries. This is great that I get a zip file, but that ain't me. If you have Brew, and I think Brew is one of my favorite things that exists for Mac. And Brew allows you to use packaging for things that aren't native. It can compile things for the particular CPU that we're using in the operating system and allow us to use very Linux similar or Unix similar applications. So what I'm going to do here, actually, is I'm going to bring this over so everybody can see it, is how we're going to actually install Brew. I should say install Terraform. And it's as simple as brew, install Terraform. Ridiculous, right? I mean, who would have thought it would be this simple? But that's really it, right, Zach?
Yeah, I love Brew. I've been using Brew for so long. It's just, it makes things so great and easy to maintain as well. It's managing that package for you now.
Yep. So while we get Terraform installed, though, and we can see it's just going to go, it's going to grab some of the packages, it's going to compile them, make sure that they're going to work on my computer, and then I can go ahead and start working with Terraform. And that would mean what we're going to kind of work on next. But what I think is really cool, Zach, what I think is cool, which, I'm an Azure nerd here at this point. I love me a little bit of Cloud Shell. Gimme more Cloud Shell. And the big reason why is I just don't want to have to worry about managing a lot of stuff on my local computer. If I have this encrypted drive with all these different resources available. So I'm going to pull up the bash shell, Zach, and I want to just run over here. If I'm right, it's just TF, right?
No, you can
Terraform.
alias it to TF, but it is, yeah, Terraform by default.
So it's just a binary CLI, and if we take a quick look, we can see it's got some really simple commands. Apply, which we'll learn about in just a minute, and then there's console to get an interactive console. If you think like in the way of like maybe IRB, or Python's like interactive shell. You're essentially saying I'm interacting with you specifically. And so yeah, Chocolatey is a really good Windows-based replacement for Brew to get things like this really simple. And yes, all praise to Cloud Shell. It is the best. So what's great is that we can also have Terraform right here in the Cloud Shell. We didn't have to install anything. It's just there. And so I want to start working very, very simply, Zach. And you've given me something really easy to work with. And so this is what I can start doing. So I'm going to share this with everybody. This is a Terraform. What would you call it? A template?
Yeah, so this is it's a main.tf file. That .tf just signifies that it's a Terraform configuration file. So that file contains the syntax is called HCL, or HashiCorp configuration language, and this is basically a HashiCorp configuration file. This is a all of the code needed to deploy this particular bit of infrastructure onto Azure.
I'm going to kind of roll through it and highlight
Yeah.
some sections. Would you kind of tell people what's going on here?
Yeah, for sure. And so I built this demo. It's just a very, very quick demo. I built it for the purposes of this live stream. And so I wanted to be verbose. I dropped some comments in there. You don't have to have those comments, obviously. But yeah, right away, we're configuring a provider. And so the provider tells HashiCorp which provider you're going to use. What are you going to be talking to here? Here we're talking to the Azure Resource Manager. So we've configured that provider. If we wanted to talk to a different cloud, we'd use a different provider. We can also use things like a Kubernetes provider if we wanted to interact with a live Kubernetes cluster. So there's all kinds of different providers you can use there. Each provider has resources under it. And so now what you see next are we're creating a resource group using the Azure RM resource group resource. And I know that's very, that sounds very redundant, but that's a resource that's inside of the Azure RM provider. And so what you're seeing here, this is a code representation of pretty much what you were just doing earlier, creating that VM. There might be a few things that I did differently here, but what I'm doing is I'm creating things. I'm also tagging them as environment demo and build AzureFunBytes. And I do that so I can have a dashboard set up to show demos very easily. But yeah, you'll see we're creating a network inside of that resource group that we just created. But if you'll take a look at like location there and resource group name, you'll see that they equal things that we are creating in this file. So location equals Azure RM resource group .AzureFunBytes resource group .location. So what that is it's syntax interpolation. And what's really cool about that is I could put the location every time, or I could just tell it, go look at what we're using for the location when we build the resource group, because that's where this is going to go. And so you'll see that syntax interpolation throughout this code. You'll see we're creating a subnet.
We're getting a little bit closer. Like you created the initial network, and now you're creating the subnet within. Sure.
Yeah, for sure. So we're creating the subnet now, and of course this is all configurable stuff. This is just what I set it to for the demo. So we created the network with a 10.0.0.0/16, but we're going to carve out a 10.0.2.0/24 for that subnet. And then we're going to create a security group. So on this particular demo, what I'm doing is I'm building a VM that's running Nginx. And so I wanted to allow port 80, so you could hit that public IP when it's all done and see that Nginx is responding. And so that's all I'm doing there is opening port 80. Yeah, and then we create a public IP. And this is kind of interesting the way that it's done, because this is a little bit different than other clouds. But the way it's done here at Azure, we're creating that public IP, and we'll assign that to the interface next. And you'll see that we create that Azure RM network interface right after. And you can see that where is it there? Yeah, there we go. So, and you can see the IP configuration that we set up as well.
Yep, so you're basically saying you're going to use a DHCP or dynamic IP address. It'll be an internal IP, obviously. And then we get a little bit, you're tagging everything, which is great. You're then adding this network interface that you created, and you're associating it with a security group so that security rule will happen, and we could actually take that network interface and plug it into something else if we really want.
Yeah, for sure. And so, I'm sorry to cut you off there, Jay. When I did this network interface, I actually assigned an internal and public IP address. But if you wanted to split that out, you could change the association later. So if you wanted your public IP to respond on 80, but not the internal, you would just do that on 2 separate interfaces. But for the purposes of this demo, I just left it alone. And then this very last bit, and this is actually kind of different. So my old demos, the resource used to be Azure RM Virtual Machine, and you would specify Linux or Windows. But now the resource is split out into 2, Azure RM Linux Virtual Machine. If you wanted a Windows, you would use Windows Virtual Machine there. But we are standing up a virtual machine, and you can see I'm setting things like the size, still using syntax interpolation for resource group and location. There's no point in copying and pasting that code or continuing to use that code. And the cool thing is, right, like this is a cool template where if I wanted to do this in a different resource group or in a different location, I wouldn't have to go and fix every time I put West US or East US 2. I would just change it in the resource group, and then everything else is interpolated throughout the code. So that's what the syntax interpolation makes easier.
And I think that, so what I'm seeing is that once you finish and you get everything you need for your SSH key, you turn on OS disk caching on that LRS, like local replicated storage disk. You're picking your image type. And then here's the thing where I think it's really cool that it's more than just the infrastructure that we're able to build, is that now you're getting to the point where you're using what's known as an extension in Azure. And these are little add-ons that you can use, whether it's you want to write a custom script in, say, Bash or PowerShell to do something on a server, or if you want to run a specific agent. So there's a bunch of predefined agents that you can use. But what Zach's done here is he said, you know what, we're going to run a custom script using Microsoft Azure Extensions. There's a couple ways you can do this. One of them is by using Cloud Init. The other is by using an extension. Cloud Init does something similar, that you basically say, these are instructions I want you to run when the server starts. And the difference, though, is that Cloud Init, I believe, only runs the first time you start a machine.
I think you're right there. And that's why the reason I did this extensions is I was actually, as I was writing it, I was rerunning the code to have it do different things. And so I didn't want it to just run once. And that's what this extension was for.
And so that leads me to one question I'd love you to answer. And so let's go up here for a second. What happens if I make a decision that I need to use a different subnet? And this has already been deployed. Would this require me to create a new version of the deployment and just move DNS to that? Or would this be idempotent enough to be able to make those changes and remove the other network subnet information?
So if you made a change, like say you deployed this and it was live and you used this code to deploy it and we were tracking state, and then you made a change to that address prefix and you reran your apply and your plan and apply, what it's going to do is whatever is required to make that change. So, and I'm honestly not sure off the top of my head if it would require tearing down the resources. It would do all of the work. The only problem is if it does tear down the server behind, if it's a live server, you
take it down.
Right. And so the big thing to remember is this is all done through API action. So whatever is required to make that change via the API is the same way it would happen here.
So I'm going to do some real basic here. I'd love to try to run this. So what I'm going to do here is I'm just going to go to your repo. Go ahead. I'm going to just clone it, and I'm going to cloud it actually in the Cloud Shell. And I think it just because it makes, I think, this situation a little easier. We don't have to worry about authentication and stuff like that. So what we're going to do here is go git clone. And so now we're going ahead and we're grabbing this Terraform on Azure demo repository. And then what I'd love you to do, Zach, is why don't you talk me through once I get in there. So Terraform.
Yeah, for sure. So there's going to be a lot of demos in that demos folder. And I just want to note right now, some of them are not up to date. I need to go back in and update them. But if anybody does take a look at those demos, wants to use them, if something's not working right, just ping me. or send me a message on Twitter and I'll get it taken care of. But yeah, you'll go into that Azure FunBytes VM demo folder. And so now that you're here, you'll see you've got your TF file, and the README is just telling you basically how to use that file. But you would normally set up your authentication because you're in the Azure Cloud Shell, you're already authenticated. So what you have to do for Terraform is you tell Terraform that you want to initialize or init that directory. So on the command line, and that's the same code base you were just looking at as well.
Mm-hmm.
Oh, I love that code is built in. Yeah, code is built into the Cloud Shell as well. In case
just wanted everybody. Yep, just wanted everybody to know. While you can work right here, let's show everybody. If you wanted to work with your locally, there is a Terraform number of extensions for VS Code, which I think are really easy. All you got to do is click install, refresh VS Code. You can start working. And the same thing as ARM, syntax, linting, you name it, auto completion. We've got it. So let's focus a little bit more here on what we're going to do with Terraform. So all right, I've got my my main.tf, and I'm going to ask one quick question. I don't want to do it in VI, so I got to be more friendly to everybody. I know I'm an old VI fart, so excuse me.
I'm the same way.
And also this has better highlighting for our viewers. So sorry everybody, I should think about you first. And what I'm going to do here is I'd like to learn about what happens if I change this. Let's not play with that. Let's got a little something here. What if I wanted to do something like the first command to execute? What we do is echo something into a file as well. So let's run the first. Let's run the first run and then maybe run a second run and show everybody how it kind of goes, just to show how the it'll be impacted in the portal, and then after that, how we make a change and what it looks like. You think that works?
Yeah, that should be totally fine. That'll show that there's a change based on your state as well, which is important.
we got about 20 minutes. I think we can get this done.
Yeah, it shouldn't take that long.
Our VM should take about 4 minutes to build. All right, so I don't need to make any changes in here now, but I'm just going to leave it open for when I do want to make a change. And so Zach, let me bring this up just a little bit so everybody can see it. All I really need to do, right, is
so first what you'll do, you'll do a Terraform init. And so what Terraform is doing is it inspects all of the files in there that have a .tf, and it pulls down all of the modules that it needs to run. So you can see it actually pulled down the Azure RM module. If you do an ls-alh or just to show the hidden folders, you'll see a .terraform folder now. That's where it threw everything. And so now that you've initialized, it's checked to make sure the syntax looks all right so far, and it's pulled down the, there you go. You can see that it pulled down that plugin, which is the only plugin that we need here. If you had several providers, it would have pulled down several plugins, but being we're only using the Azure RM, that's the only one it needed. So if you do a Terraform, go ahead if you want to take a look in there.
So that's just an executable. It's statically linked. So anybody who's curious what this file is, this is just a binary that connects Azure Resource Manager to our Terraform installation, correct?
Yeah.
Cool. That's kind of what I thought. It was just a binary. So let's go back to just CD.
Yeah, Terraform is super duper lightweight. I mean, in all aspects, it's lightweight and very powerful.
So just to show everybody, it's just in there. So we've got this main file that we've got over here up in our editor. Do you think there are any changes I need to make, or how about I actually just make one little modification? I don't know.
You could, I mean, if you wanted, you could have it deploy. And so you haven't deployed yet, but if you wanted to change something, you could totally change something. You could change, I mean, any number of things in there, really.
Why not?
Yeah, that's totally
because I already have it's got my pub key in that directory. Cool. I'll just use my username Jay because that's what it is here.
Yeah, no worries, no worries.
Okay, so I'm gonna just save my change, and then what I'm going to do, if I'm right, Terraform Is it apply?
So what I would recommend doing first is a Terraform plan. And so when you do a Terraform apply, it's going to run a plan anyway. But a Terraform plan will show you this is your current state, which yours is going to be there's nothing, and we're going to create everything. You can see that it outputs literally everything that's about to happen. The cool thing too that I want to mention about a Terraform plan, you can actually send this. Oh, go ahead.
Just want to see, is it this thing out?
Yeah, dash out, and then give it a name of a file. And I usually call it like plan.out or something like that. So it will actually output, it'll send that Terraform plan output to a file, and then you can share that file with your team, and you can have them review it using Terraform. I think it's Terraform output and then the plan file name.
And that's another binary.
Yeah.
So that's what everybody, that's what it looks like when you open a binary. So let's close that. Cool.
So now if you do Terraform, is it Terraform? Actually, maybe Terraform show.
Well, let me also make sure everybody can kind of see this. So the plan is all those instructions that you've asked us to use, basically, right?
Yeah. So this is a more it's a more visual, showing you. So say you've already deployed this, right? Say you've deployed it and you added some changes. This would be more not necessarily more useful, but it would show you what you're subtracting, what you're adding, what you're changing, and it's really easy to see, especially with the color there showing you like green for addition, red for deletion. It shows you what changes are about to be made. So based on your current state, if you run an apply right now, this is where you're going to end up, is what it shows you.
So do I need to specify a binary?
No, you don't have to. You can.
Or I should say the template. I don't have. Not binary. I don't have to specify the target file.
No, and actually, I wouldn't specify it, just to show if you don't specify it, it will ask you if you're totally sure, and you've got to type yes. It won't take a Y. I actually I want to get a PR in there where I can have like an Easter egg where I can put like totes or something and then have it accepted, but I haven't done it yet. But you can see that it's showing you the same plan output.
Yeah, it's just warning me this is all the stuff that's going to happen. And I like this known after apply, because if I'm right, once I finish this, I should be able to just do Terraform Plan if I need to get information about my infrastructure, because all those variables will eventually be filled in.
Yeah, it should. You should also be able to get that output. You can do a Terraform output and then ask for specific resource information, and it'll spit it out on the command line for you. Yeah. So now
what I love this kind of verbose information of what's going on.
Yeah, no, it's totally cool. And you can actually watch in the portal as it's being built, obviously, because this is actually building on your account. But the cool thing, right, is you didn't have to specify any kind of tenant information, subscription information. Oh, what is that? Let's see. Invalid parameter. Destination path for SSH public key is currently limited to.
So this is because I was futzing around with it. And now we can show what happens. This is great because we can show what happens when you make a mistake. So you know what I'm going to do? I'm just going to go ahead and check it back in. So git checkout. And then what's the file name?
That would be main.tf.
Thank you. So I'm just getting back the original version from your repo. That's a great thing if you ever have something in GitHub and you want to get the file back because you made a change, you're not really sure. I'll always use this method. So let's just do that. So now we're going to do, I'm going to do a plan again because I made some changes.
So being that failed with an error, the Terraform TF state file might not have updated. So we'll see what happens here, but it might tell you that nothing is done, and it could be problematic because you might have deployed a few things, like you probably deployed your resource group and network and what have you. I actually planned to add, so it did get something down there. So let's run an apply and see if it finishes out here. There are some times where you hit an edge where something is kind of half deployed depending on the error, like the level of the error. And so it's just something important to mention.
So I also like the idea of breaking something on purpose and watching how to fix it. I enjoy this.
Yeah, this is great information, and it's live, right? Like, this is not, we didn't plan any of this.
it's the break fix admin in me. What can I say? I spent a lot of years as a system administrator listening to people say to me, "What happened to this change? Can you find?" And sometimes you have to go and look at the broken change and say, "All right, let's get it back to what it was, and then figure out how to get everything working from there." So while this is all applying, like I think we should do is go to that resource group and let's take a look at it. All right.
Yeah, totally. You can see things building and propagating in the portal.
I'm just going to open it up in a new tab, just make it easier. And let's go to AzureFunBytes demo. And so I'll kind of bring you over here. So we'll see that the virtual machine is being created right here. And what we can do is we'll go in, make this a little smaller so you can see it. We can see that at least the portions of the Terraform file have completed some of the initial deployments. There we go. We just keep looking. And if we go back here, we can see the VM still creating, but all those other resources that it asked for in order started deploying. So what we're doing is we're making sure that using declarative language, using, I believe you called it HCL, we state in order what we want, how we want it, and when we want it. So we've got some questions here from Odin Hassan. Any comment on Terraform landing zone for CAF? You know what that's about, Zach?
I honestly don't know what that is. Can you elaborate a little bit, Odin? And while we're waiting for that too, Jay, I want to mention, you did mention that you're putting it declaratively in order, right? Something cool that I forgot to mention about Terraform is the way Terraform works. When you run the Terraform Plan, what it's doing is it's taking a look at everything you're building. If you had multiple .tf files in there, it would take a look at all of them. And what's really cool is it builds a dependency graph. So like, you know how we were using syntax interpolation for some things? It knows to get that syntax, or to get that interpolation done, it has to build certain resources before other resources. So the cool thing about Terraform too, if it can build things in parallel to make it faster, it'll do it. But it makes sure that it builds things in order that have to be built in order. You could write it all out of order and it would figure out how it needed to do it. And so that's just another neat part of Terraform.
So I'm guessing that right here, it's just waiting on validation that the server is up, even though I believe if I go here, I don't want to set up Bastion, but what I'll do is I'll just look at the serial console, which is one of my other big favorite things. I didn't enable boot diagnostics.
Oh yeah, on this VM, it's probably not enabled. Yeah, it's a really cool feature.
Yeah, I can go ahead and just go to updating diagnostic settings and update some of these things where we can get additional logging from the machine. But what we can do from this VM is we could eventually see that it's been built. And then when everything is finished, as far as the, I think this is probably waiting on Nginx, is what I'm guessing is going on. That's why I wanted to get the serial console, because I think what's probably going on and why we have this delay is it's waiting for the process of Nginx to be completed with the extension, is what I'm guessing, because it wants to get a, it sends back a completed or failed, correct?
Yes, yeah, it will tell you that everything's completed, or if you had any errors or warnings or anything like that. And I see Odin dropped the a URL to the CAF Terraform, and it looks like that's I apologize for being late there to unmute. I was taking a look at that cloud adoption framework landing zones for Terraform. Honestly, Odin, this is something that I'm just now seeing right now, so I don't have any comment on it right now, but I will definitely take a look at it. I was not aware of this myself.
Cool. Let me get my boot diagnostics on now.
Yeah, Odin, if you want to reach out to me on Twitter, we can follow up after the live stream as well in regard to that. It's something that I haven't seen yet.
So many people have used AFDF for their temporary storage blobs. It's kind of funny.
Yeah, it's I love running into those walls like randomly, like what?
Cool. So let's save this. Okay, so this applied, and I guess that means that I think that that script finally finished. Let's go ahead and go to virtual machines. We'll go to the FunBytes virtual machine. We've got the public IP address, the hardware that you asked, the virtual network subnet, the resource group that you requested, the size, the whole 9 yards. So now let's copy the IP address. And Nginx is up. We never had to SSH into anything. It all happened through one like straight template pipeline. And so before we kind of move to the end, is there any kind of tricks that you can show me that you have on your machine that maybe I can just see, or maybe a cool looking, more advanced Terraform template that you can just be like, you know, you did step one, but here's just a quick one because I think we got about 10 minutes left.
So I know I have some more advanced ones in that repository. Just I need to go through them to make sure they're working. There's some syntax that changed. So as providers change, you have to make sure that you're testing, which I failed to do on this repository personally. So I haven't caught a lot of those errors, but I can show you some of the older syntax where you're doing a lot more complex stuff if you want me to show that.
Sure. Let's do it.
Okay. Can you see my screen?
Let me bring you up.
Yeah, no problem.
There you are. You just turn up the size just a smidge.
Yeah, no problem at all.
It's a little small, and I only say that because there you go, great. Because I'm an old man. Just I think we're both old men, but my LASIK only works so well.
Yeah, no, I totally understand. So this is my repository, the Terraform on Azure. This is just a lot of demos that I've created and used throughout my time working with Azure and Terraform. But I think this is an interesting one, and I need to update this. So this is a more complex. So the one that we showed today was just for demo purposes, obviously. We didn't want to get too complex yet with it. We wanted to start off there. But you can see we have a main TF. We have a different Kubernetes pods. And if I take a look, actually, let's see if it's easy enough to just open it here. But so my main.tf here, I'm actually setting my backend, setting my provider. You can see that you can break things out into different pieces. And so what I'm doing with this Terraform is I'm creating a Kubernetes cluster. And you can see that you can use things, where is it here? You can use more advanced things. This syntax is actually, oops, sorry about that. This syntax is actually deprecated. But this code does work with older versions of Terraform and will be updated shortly. But with this, we're creating a Kubernetes cluster. The cool thing about this code base is after we create the cluster, we actually switch to the Kubernetes provider, and then we deploy into that cluster that we just created, all in the same code base, all in the same deployment. I don't have to deploy twice or anything like that. Terraform knows that it has to wait for Kubernetes to come up to interact with it. And just switching the provider and giving it the host context, it knows what to do with the rest of it. Something else that's neat with Terraform, you can split out your variables. If you want to set up variables, you can do that in a variables file. You can do it in the main TF as well. And something else that's really neat, you can set outputs. And I didn't do that in this demo. I probably should have done it, but outputs are things that you can show upon completion of a Terraform run. So all of this stuff will spit itself out after this Terraform runs. You can see I actually gave myself a little cheat sheet here that I call configure. And basically this is so when I was demoing live, I could just copy and paste these commands and show people how it all works and how to connect to it immediately. So you can do a lot of cool stuff. You can get a lot more in depth, but I really like showing that demo of standing up Kubernetes and then deploying into Kubernetes and interacting with Kubernetes in the same code base. It's very powerful.
So is there one thing you could show me? Do you have that demo up anywhere? Like, did you pull it up anyhow?
I don't have it running. Do you mean, do I have it deployed?
Yeah.
It's not deployed right now.
Okay.
But we could also look at that for a future stream as well.
No, what I wanted to actually, no, I meant the one that you made today.
Oh, sure. I can, I don't think I have it deployed, but I could actually.
The only thing I wanted you to show us is after you run one, how to destroy things that you've created.
Oh, sure. I mean, we can show it on yours as well.
Let me do that. Yeah, let me do that. Give me
just for the sake of time. Whoa, sorry about that.
Probably recursion. All right, let's go to here. And let me bring up.
I've created a portal.
Wow.
Sorry about that.
All right, so here we are with my machine. Now I'm going to go back to the Cloud Shell. And so what I want to do next, go back to that repository.
Yeah, I was going to say, take a look at the files in there as well. You'll see a .tf state file.
Which one? What's the name of the
Terraform? Terraform on, yeah. There you go. And so now, yeah, you'll see the .tf state file there. So that's a local Terraform state being tracked, and that's good for testing. That's not good for production. You can actually tell it to store that state in a third-party service like Azure Storage, and that way you have a centralized state somewhere. But that's how you're tracking state.
And that's just JSON as well.
Yeah.
Okay. So I want to destroy everything. What's the next thing to do?
So if you want to destroy everything that you're working on, you literally Terraform destroy. Odin, I do not believe it stores secrets, but honestly, that's something that I have not really looked into. I don't believe it stores them, at least clear text, and it's something that I haven't mentioned. If you're not using something like Azure Cloud Shell, and you need to set up your tenant ID and you need to set up your subscription ID and all of that sensitive information, I would recommend exporting those as environment variables and not storing secrets inside of the code base.
So like using, if you want to Vault as a native, or using like Azure's key service native to get that done.
Yeah.
That's what I'm taking a guess about. So anyhow, I think that means we've kind of reached just about the end of this whole thing. And when we get to the end of this thing, what I end up doing is being silly and playing a little musical goodbye. Let me see if we can get both of us into this. Yeah, I'm just going to play a little something as we say goodbye to everybody.
Okay. I
wish I could figure out how to make it so that this is smaller and it shows our two heads, but it is what it is. I maybe we'll just go ahead and start wrapping things up. Oh, Odin, thank you very much. Hey everybody, before we get going, we got about 2 minutes before everybody we start saying goodbye. If you have any more comments or questions for myself or Zach, please let us know. And if not, I think what Zach, you and I can just start doing. Where's Meadow? She's in the other room, chilling with her mama. Anyhow, we've reached the end of another one of these, and Zach, you really helped all of us with Azure FunBytes learn yet another way to work with these fundamental tools on Azure to build complex or not so complex things. Well, thank you very much, Zach, for joining. I really, really appreciate it.
Yeah, no problem, Jay. Thanks for having me on. And yeah, if anybody has any questions or wants to chat afterward, feel free to tweet or hit me up on Twitter. I think my DMs are open as well, which is kind of a scary thing.
Yeah, let me get your Twitter handle for everybody just so they have it. I can't remember if it's in your thing on the bottom there. Let's grab it. Here you are. Sorry. Here we go. Here's a little bit of Twitter love. So anybody, thank you very much. Zach, I'll catch you next time. Thanks so much.
No problem.
Take care. Enjoy yourself. Have a great day. So that's just about it for this week. I'm getting really close to moving. I know I keep saying this every week, but I'm going to keep doing these. And I got something special for you next week. None other than Donovan Brown. He's going to join me next week, and we're going to talk about Azure DevOps and DevOps in general. Azure DevOps is a huge, huge tool that you can start using to go beyond just the walking and start running in the cloud. So until next week, feel free to send comments, questions to the Twitter at Azure FunBytes. If you want to reach out to me personally on Twitter, it's right there. It's at jdestro. And that's really, what can I tell you? It's been fun. So until we meet again next week, yep, Donovan is going to be awesome. I'm really looking forward to it. But until we meet again next week, thank you so much. I'm Jay. I'll catch you next time on Azure FunBytes.